Hello everyone, my name is Robert Ho. In this video, I'm gonna discuss Chapter 6, Telephony Fundamentals. You can find this in your textbooks, Convergent Technology Professional Plus. The table of contents, introduction, then we're gonna talk about telephony fundamental, 5 major components of telephone, 2 general categories of telephone system, public and private, voice transmission, the difference between in-band and out-band signaling, and the last one is public switch telephone network and a private phone network, which is PBX. Circuit switching versus packet switching. Okay, in circuit switching, the path is decided upon before the data transmission starts, the communication session between the two communicating bodies. The route is dedicated and exclusive and released only when the session is terminated. However, in packet switching network, the packets are sent toward the destination irrespective of each other. Each packet has to find its own route to the destination. There is no predetermined path. As you can see here, with the circuit switch channel, you need to have an established circuit before you start the communication. As opposed to packet switch channel or network, the packets can be sent to many different routes instead of establishing the circuit. In packet switch network, it breaks data into chunks and wraps the chunks into structure called packets. And each of the packets contain, along with the data load, information about the IP address of the source and the destination nodes, sequence number, and some other control information. A packet can also be called a segment or datagram. Circuit switching is a known and expensive and is what public switch telephone network uses. Packet switching is more modern. In circuit switching is more reliable than the packet switching because when you have a circuit dedicated for a session, you are sure to get all the information across. When you are making a PSTN call, you are actually renting the lines. Okay. So what are the pros of packet switching networks? The first one is network efficiency. Okay. This system packets, okay, in circuit switching network, the system is inefficient for computer network because it often means that other devices cannot use the network until the first two have finished communicating. So packet switching network avoid this problem by allowing each packet to find its own path to the destination with no dedicated connection needed. The second benefit, the second benefit or the pros of a packet switching network is the reliability. All networks lose data in transit from time to time. With packet switching, however, this is not a problem because when the receiving device comes to examine the packets, it can easily detect if one is missing and request for that packets to be resent. The third one is resilience. Packet switching networks are resilient to change. Packets find their way to their destination with the help of routers, which use their knowledge of the network to send traffic along the most efficient route. If the network changes, for example, or if the network link fails, routers are designed to detect this and send traffic another way. With circuit switching network, however, if the link carrying the connection between two devices changes, then manual intervention is often needed in order to get things running again. The next one is cost. Okay, the last pros of a packet switching network is the cost. The versatility of a packet switching network gives many cost benefits. They can be used to carry voice and video traffic across the same network that your data uses, meaning that you don't need to pay to have separate computer and phone network installed. Packet switching makes for high level of scalability, meaning that it is easy to expand your network cost efficiently. Routers are able to detect new devices or links are added to the network and adjust the destination packets accordingly. Telephony fundamentals. In order to understand how the sounds process, students should be familiar with a number of terms related to sound theory. This term includes frequency, amplitude, and attenuation. What is frequency? Frequency is the number of cycles per second that sound wave vibrates. A higher pitched sound or tone vibrate at a higher frequency rate, and lower pitched sound vibrate at a lower. If you see this in the diagram, if you have a low frequency, and the other one is a high frequency, you see there are more cycles per second. So that means a higher pitch sound or tone vibrate at a higher frequency rate. They are more frequency, as you can see in the previous one here. Where is it? This one. Okay. Amplitude describe the pitch of the sound. Amplitude determines the volume of the sound. As you can see here, it's quieter, it has low amplitude, and high volume, which is louder, has high amplitude. Attenuation. When sound travel through the medium, its intensity diminishes with distance. Also, when the sound wave is attenuated, the amplitude is decreased. Therefore, you need to have some devices in between if you have a long distance, for example, like repeater or switches.